Good morning, everybody. Welcome to today's class. Okay, last week we started with something different. We'll talk about programming paradigm. Then we established what a programming paradigm is. We didn't actually go in so much deep. Then the assignment was for you to write what is Imperial Programming and Procedural Programming. Okay, from there we are going to start from today. Although last week, why the reason for it is so that we understand that our assembly language and our Pascal language, I'm very sure most of you by now you would have known that your assembly language and your Pascal language are under what is called Imperial Programming. And today we're actually going to view in details what they actually have in connection. And the reason for it is that last week we started talking about the syntax and semantics of assembly language, and we're able to understand that how the syntax is how messages are being written, and the semantics are the actual meaning of each sentence or each word that is being given in a statement. Now we are going to go straight to what is called Imperial Programming, and before we go into that, let's first of all discuss this programming paradigm briefly before we go into what is called this Imperial Programming, so that we understand in details what it actually entails. Okay, I'm going to share my screen now. I'm already sharing my screen, but I'm going to minimize so that you see a diagram of how programming paradigm looks like. Okay, on the left hand side here, I believe you are seeing my screen, which I'm already sharing. So on the left hand side here, we have imperative programming. Then on below it we have procedural programming paradigm. Then under it we have object-oriented programming. The last one there is what is called parallel processing approach. Then on the right hand we have your declarative programming paradigm. Beneath it we have logic programming paradigm, functional programming, and database processing approach. So this is how your programming paradigm looks like. This is how it looks. Now, let us understand what really programming paradigm is. So, a programming paradigm is a style. A programming paradigm is a way of programming paradigm. Last week we established that programming paradigm is actually what is being used to determine how a program should be. So now we're going into the text of it so that we understand how fully what it actually means. So a programming paradigm is a style of programming. So that is to tell you it's actually styles or way of languages make it easy to write in some paradigm, but not others. That is now the language which you are talking about now is your programming language, just your human language now. So one thing you should understand is that you never use the phrase programming language paradigm. The phrase programming language paradigm in the sense that there is no need for you in the sense that programming language paradigm itself, it's not ideal. A programming paradigm is not a language. It is not a language, but rather a style or a way of programming. Now, a paradigm is a way of doing something. A paradigm is a way of doing something, and not a concrete thing like a language. So there are several kinds of major programming paradigms, meaning there are several kinds of there are several kinds of major programming paradigm. So I can actually rephrase it to be that there are several kinds of programming styles or programming ways. So now the first one here, we have the imperative, the logical, the functional, object-oriented, and so on like that. So all these things are styles or way of programming. When we go into details, then you understand what is that. We are going to actually take this imperative function and we're going to take that so that we understand what they actually, whether for application development, programming of machines, or development of business software. The developer, you as the developer, you have to decide which programming language to use before the first line of code is being written. As a developer, no matter any project that is being given to you, first of all, you have to understand the project. Then before concluding, then you have to conclude on the type of programming language that will be good for it. Because you understand that there are different kinds of, like I said earlier, there was a time I said that we have almost 700 programming languages. And all these 700 programming languages, they are used differently. They embark upon determines how. I made mention of something sometimes. I said that in a situation whereby you are programming, you are about to develop an application that has to do with artificial intelligence, there is a kind of programming which can run efficiently for it to use to implement, and it will run efficiently. Then if let's say for game, there is another type of an application which will work for it. You use programming language like Python, and for your games and the rest of them, you use things like your Java. So the reason for it is that it has been discovered that Java actually and efficiently with the hardwares, because most of the time your game uses hardwares. And since your games are using hardware, Java is actually the right one to use for it because it runs concurrently smoothly with your hardwares. Programming a game with your Python most of the time tears your hardwares. So these are things which we have to understand. So that is why it's been said that before any application is being developed or programming of a machine, the developer, you as a developer, you have to decide which programming language to use before the first line of code is being written. There is a wide range of programming language available, but each of them can be assigned to one or two fundamental programming language. That is that two programming language can fall under two or more programming language. One programming language can fall under two programming paradigms. Okay, now there's a wide range of programming languages available, but each of them can be assigned to one of two fundamental programming paradigms: imperative programming or declarative programming. So majorly, your programming paradigm is actually being divided into two. Before it is being distinguished down, it is being broken down. This is, see it again. This majorly, you have your imperative programming paradigm, then here you have your declarative programming. So on your left hand side, every other thing that is under your left hand side is under your imperative programming, while every other thing on your right hand side is under your declarative programming. This is actually what that sentence is actually saying. Everything on your left hand side is under your imperative programming paradigm. Then everything on your right hand side is under your declarative programming paradigm, because you can see how the arrow goes. So now back to our material. Now, what is imperative programming? What is imperative programming? Imperative programming is from a Latin word, which means from a Latin word imperial, or which connotes command, and is the oldest programming paradigm. A program based on this paradigm is made up of a clearly defined sequence of instruction to the computer. So now, imperative programming deals with, is a kind of program that clearly defines sequence of instruction to the computer. That is telling the computer how to carry out an instruction. It tells the computer system how to carry out an instruction. The source code of imperative language is a series of it specified to the computer and when in order to resolve control the command controls the code in system oriented. Commands is actually telling your system that if it is using your system. Take for instance, when we are talking about your assembly language, we said that remember that we said that assembly language is under imperative programming, in the sense that your assembly language is used to tell your microprocessor of what to do per time in every operation. So your source code is actually interacting with your hardware, telling the system what to. On the other hand, the code is easy to understand, and on the other hand, many lines of the text are to describe what can be achieved with a fraction of command. Using declarative programming have over declarative programming. Imperative programming, the source are actually little, because it's actually of what to do. And comparing it now to your declarative programming, most of the times when you see declarative programming, most of the time they are abstract in nature. And when dealing with declarative programming, you understand that after implementing your declarative programming, your machine, that is why only interacting with the hardware, meaning that of operation to your system. Okay, Pascal. we have Angle, we have Python, and we have Ruby. Examples of your imperative program. These are them listed here. Fortran, Java, Ash, we have your C++, we have your assembly, your basic, we have your combo, Python, all these things. The can in turn be assigned to 3 imperative programming can be further subordinated. The first one here, imperative, you're structured. Then let's understand what each are now. The structured programming style, which is the first, what is it? Programming style extend the basic imperative structures, sequencing. This approach is based on a desire to limit or complete. This approach is based on a desire to limit, avoid jump statements that may be complicated. Now, your imperative programming is broken down into 3 segments. That is simplest programming. It is actually one of the subordinates of your imperative programming. The structured programming is a programming parameter aimed at improving the clarity, quality, and development time of a computer program by making extensive use of this. For your selection, you have things that else. These are most of the times when using this word, it to understand that for it to carry a condition is not being met, then it goes to the next operation. Else, it comes back what your structured programming is actually telling, which is your if and understand that this is actually called a repetition or a loop. Actually, considered to be a repetition or a loop because most of the times an iteration or operation has to be carried out. Before it can be carried out, a condition has to be met. So this is what, and understand that your structured programming is under your imperative, is one of the subordinates of your imperative programming. Your structured programming, your structured programming is a subset. Remember that your procedural programming is still under your imperative programming. It's a subset of your programming, your procedural programming that enforces a logical structure on the one of the reasons of your structural programming. One of the reasons that it's been adopted is that it is unlike your declarative programming. Your declarative programming deals with what is called abstraction. Abstraction. Most of I don't know if I've actually discussed abstraction with the class. Okay, for abstraction, which is under your declaration, what abstraction is actually telling, abstraction is the of hiding unnecessary detail, hiding or cascading unnecessary detail to this. When it comes to modification, it becomes most of the time it might be comes to your when it comes to your imperative programming now under your structural programming, a modification is being with the help of your if, then, and else. So these are the majorly what actually telling you, or it's actually saying. Okay, now talk about under these things about your procedural programming, which is still under your declarative programming. Okay, it's still under your imperative programming. Yes. Now, your procedural programming. Your procedural programming is the device the tasks of program. The procedural approach divides the tasks a program is supposed to perform into smaller subtasks. The procedural approach divides the tasks of a program is supposed to run into smaller subtasks. Are individual. This results in a programming also be used in other programs. Modular programming module goes one step further by designing and testing the individual program components independently of one another. Okay, now the approach in programming, it helps in break modules or your taxes and by a program into, it breaks the task that is to be carried out program into units, into smaller units. Modular programming. Your modular programming goes one step ahead of your procedural programming in the sense that these programs have been these tasks which are broken down into units. Your modular programs test each of these tasks. That is independent of one another. So you can say that the taxes into bits. Then your modular programming comes and it tests each of these tasks which have been broken down into bits. By your procedural programming, it tests them individually, one after the other, to ascertain if each one of the tasks are correctly implemented. That is why you discover that when it comes to your imperative programming, it is very, very ideal to say that it is it is one of the easiest language because modification is actually very, very easy. And secondly, it is very easy to understand where you are having an issue. It is very easy to understand. You don't actually need an algorithm to implement, you don't actually need an algorithm to implement your imperative programming. Unlike your declarative programming. A procedural language is a type of computer language, steps and procedure within each programming context. A program. It contains functions and commands to functional tasks or a program. Now, you understand that your procedural is specifies structures. That is, it specifies what or how the steps or the procedure for a program is to be carried out. That is, it breaks each of these tasks into bits. Then it also contains a statement, that is statements, which every programming. Your modular programming separating the functionality of a program dependent interchangeable model. Your modular programming can help you in a situation whereby you need to replicate a function in another program. Your modular programming it helps you to break your program into bits. That is, understand that it is also part of your procedural programming. But now, your modular programming, it tests each one of these programs which have been broken down into bits. It takes them individually. That is, it separates each one of them. And since it has been separated and tested individually, you can pick out one of the modules, one of these units, and replicate it in another program entirely, in another different programming that needs that module. So that is what is being said, that your modular programming is a software design technique that emphasizing separating functionality of a program into independent, interchangeable modules, such that each contains it contains everything necessary to execute only one aspect of the desired functionality. So you know that for this module, this is the functionality which this module carries out. With the help of your modular programming, it gives you the technique for you to pick up this program and replicate it in a different program entirely, in a different project entirely. Okay, now. Okay. We're going to actually view the fundamental of this, or the fundamental of your imperative programming and your imperative programming. Imperative programming language differs from declarative programming. Your imperative programming differs from your declarative programming. Okay, now, imperative programming differs from declarative programming on one fundamental point. Now, this is the underlying point between your imperative programming and your declarative programming. Imperative programming focuses on how. It focuses on how to carry out an operation, how to carry out a function. What your declarative programming focuses on what? So this is the major difference between your declarative programming and your imperative programming. Okay, now imperative programming language are composed of step-by-step instruction, which is how. Your imperative programming focuses more on how a project or how a function or an operation is being carried out. That is why I keep repeating it. That is it functions very well with your hardware. Functions very well with your hardware. Remember when we are talking about your assembly language, we talked about your OP codes and your operand. Your OP code and your operand. That is where to fetch a data and what to do with the data. Okay, now your imperative programming are composed of step-by-step instruction, which is how for the computer. They describe explicitly which steps are to be performed in what order to obtain the desired solution at the end. Your imperative programming composed of step-by-step instruction, which is how for the computer. They describe explicitly which steps are to be performed in what order to obtain the desired solution at the end. By contrast, in declarative programming, the desired result, which is what, is described directly. It becomes clearer when using a cooking analogy for instruction. Imperative programming provides recipes. Declarative programming contributes results of finished meals. So now, using a cooking analogy to explain what declarative programming is and your imperative programming. For your imperative programming, using the analogy of a cooking instruction. Now, imperative programming tells you on how a meal is being cooked. It provides you with the recipe which is needed. It gives you, okay, it tells you, take for instance, you want to cook jollof rice. It tells you, okay, you need rice, you need tomatoes, you need maggi, you need onions, you need groundnut oil, you need fish. The list goes on like that. Then it tells you, okay, now this is what you have to do. You have to now, first of all, you boil your rice. After boiling it for 20 minutes, let's say 20 minutes, you bring it down. Then you wash it and keep it. Then you take your pot, put on the fire again, then you put your groundnut oil. You fry your tomatoes and your onions. Then you begin to put other ingredients into it. Then you allow it to steam for some minutes before adding your rice. Now, this is how imperative programming works. Imperative programming gives you instruction how each operation is to be carried out. But for your declarative programming is not like that. Your declarative programming just only gives you the picture of the finished meal. It gives you, that is why I say that your imperative programming deals more with abstraction. That is, it has hidden all the details. So it is now left for you to figure out how the whole process went. That is why it's been said that for your imperative programming, at the end of your imperative programming, you still need an algorithm to interpret. You still need an algorithm to interpret each operation that is to be carried out to your system. Okay, this is where we call it a day in today's class. Okay, now For your programming, for this course, I'm actually going to give an assignment for this course. Now, the assignment is going to be, now, give the advantage of declarative, your imperative programming over your declarative programming. Give the advantage of your imperative programming over declarative programming. The assignment is the advantage of imperative programming over declarative programming. Then the second assignment is the advantage of declarative programming over imperative programming. The fourth assignment is advantage of your imperative programming over declarative programming. Then assignment number 2 is the advantage of your declarative programming over imperative programming. The email still remains sharonchris29@gmail.com. sharonchris29@gmail.com. And in case you need more clarity based on what has been discussed, you can reach across to me on 08133 121 309. Please make sure you get the assignment. Make sure, in case you didn't get the assignment, you can get back to me. I come again. The assignment is give the advantage of your imperative programming over your declarative programming. Then give assignment number 2. Then advantage of your declarative programming over your imperative programming. sharonchris29@gmail.com. And the email is still sharonchris29@gmail.com. And my phone number is 08133 121 309. This is time for questions. Questions, please. Questions, please. Before we exhaust, just remaining 2 minutes for the end of this class. Questions. Please make sure you get the assignment. Make sure you get the assignment. Hello? I'm hearing some noises. Hello? 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 Okay. Hello? Hello?
Students, you have been unmuted. Please. If you have any questions, please.
Okay. We've come to the end of our class. Thank you so much. Please, in case of anything, you can get across.
Immediately.
Customer care, he send me back to